Welcome everyone to the channel today. We are starting our series on straight line graphs. So today we will talk about the length of a line and also to talk about the gradient of a line. Alright, so now let's start with the length of a line, how the formula was derived. If we know how the formula was derived, even should we forget in the exam room, I think we can go back and prove it ourselves. So now consider 2 points. Let's say we have point P, which is x1, y1. Point Q is here, x2, y2. Then we have joined these 2 points together by means of a straight line. If we want to find the distance between these 2 points or the length of the line between these 2 points, this is the formula that we use. But how did we get the formula? Well, we took the formula from Pythagoras theorem, all right? That says that if you have a right-angled triangle, all right, like what we do have here, then the distance from here to there square plus this square should be equal to the hypotenuse square, right? Okay, so that's what we did. So P cubed now becomes the hypotenuse. So the length of P cubed will be the square root of the distance from x1 to x2, which is x2 minus x1 square, plus the distance on the y-axis, which is y2 minus y1 also square. So this is how come we derive this particular formula. So keep this formula in mind. We will use it a lot in this presentation. Now let's talk about the gradient of a line. When we say a gradient of a line or the gradient of a line, we are basically talking about the slope of the line. Okay, so the bigger the slope, the bigger the gradient will be. Okay, the steeper the slope, the bigger the gradient. The flatter the slope, all right, the smaller the gradient. Okay, so that's how it's going to look like. So still we have the same diagram, but for gradient, what we do is that we use the rise, okay, over the run. So the rise corresponds to the y-axis or the vertical line, right? So the change in that is y2 minus y1, and then the run is the horizontal or the x-axis, so that is x2 minus x1. All right, so what about midpoint? When we say midpoint, then we are talking about the middle point in between 2 points. So if you have 2 points, say P and Q, then the point in between them is the point that, in this example, we are calling M. So how do we find the coordinates of M? Well, add the corresponding x values and divide by 2. So x1 plus x2 divided by 2, and then add the corresponding y values and divide by 2. Therefore, y1 plus y2 divided by 2. All right, that reminds me, let's go back to the gradient. I want to highlight something. If you look at the gradient, y2 starts and x2 starts, okay? Do not start with y2 and then start with x1. You will get a wrong answer. All right, so to find the midpoint, just add the x values and divide by 2, add the y values, divide by 2, and we're good to go. So at this point, I want us to consider examples and see how we can apply these 3 things that we've come to see right now: the length of a line, the gradient of a line, and then the midpoint of a line. Let's see how to apply these. So this is the first question that we have. The question says, find the length of the line segment joining these 2 points. Okay, and then we said that so the first thing we want to do is to call this maybe x1, this is y1, x2, y2. Now, so the length of this line will be the square root of, all right, now you can say x2 minus x1, all right, all square, plus y2 minus y1 all square. So this is the formula for the length of a line, and this is what we came to say, okay? And that's exactly the same formula we are going to use. Okay, so we will get the square root of 5 minus 2 all square plus 0 minus 0 all squared. And now 5 minus 2 will be 3, and 3 squared is 9, so square root of 9, and that is 3 units. Okay, so this is how to apply the formula to solve problems. How about the second problem? Question 2 says that we should show that this particular triangle is a right-angled isosceles triangle. What does it mean to have a right-angled isosceles triangle? Well, an example is this. You have a right-angled triangle, okay, but two sides are equal. So this is what we call the right-angled isosceles triangle. So the point that we want to make, so for example, if this triangle is called ABC, then we want to prove that AB is equal to BC. If we are able to do that, then we have shown that it is a right-angled isosceles triangle. Okay, so this is something that Cambridge can ask you. So is this the distance from A to B should be equal to the same distance from B to C, okay? Because those lengths are what we are arguing that they are the same. So let's first take AB. All right, so that will be the square root of, now let me bring those two coordinates here. A is negative 1, 10, 0, sorry, and then B is 1, 6. Okay, so let's say this is x1, y1, x2, y2. All right, so we are now going to have x2 minus x1, so that's 1 minus 1 or square, okay, plus 6 minus 0 square. And this is going to give us, you can just even put the whole thing on the calculator and just know what you are going to get instead of worrying yourself about the step-by-step thing. All right, so calculator tells me that I'll get 2 root 10. Now let's deal with BC. What would we get? So that will be the square root of, let's bring the coordinate BC here. So B is 1, 6 and C is 7, 4. All right, so we can say that this is x1, y1, x2, y2. All right, so we are going to get 7 minus 1 all square plus, then we have 4 minus 6 all square. And then we can put it on a calculator. So we have the square root of, that's 7 minus 1, that's 6 square, plus negative 2 square, that's 4, right? So the calculator tells me that it is 2 root 10. All right, so since the length of AB is definitely equal to the length of BC, triangle ABC is our right-angled, all right, isosceles triangle. All right, so that's it. That's how to prove it. Basically, you want to show that two sides are equal and you are good to go. All right, okay, let's continue. So this is a third example that we want to consider. It says that we should find the distance, right, between 2 points. Well, no, it says that the distance between 2 points is rather 5, okay? So we should find the possible values of A. Cool. So there was a distance formula, that's the square root of, if we take these two values, we can see this is x1, y1, x2, y2, right? So x1 minus x2 minus x1 will be 2a minus 6 all square, plus then we have a minus 2 all square. Be careful because this 2 is already negative. Be careful. That is one thing that I normally see students making mistakes, and unfortunately I have to mark them down when I see that. Okay, so this will give us 2a minus 6 square plus a minus plus 2, okay, or square is equal to 25 because I just squared both sides, all right? Okay, so if I have this, then I have to expand. If I expand this first bracket, I'm going to get 4a square. Now 2a times negative 6 will be negative 12a times 2, that's negative 24a. Then negative 6 squared is 36. Let's expand the second one. We have a squared. A times 2, 2a times 2, that's 4a plus 4 is equal to 25. All right, so let's group the like terms. So this a squared plus this 4a squared will give us 5a squared. All right, then the next thing is that we have negative 24. Okay, so we have negative 24a. Now we are going to add it to the 4a here. All right, and then our answer will be negative 20a. Then we have the constants. We have 36 here. All right, we are going to add it to the 4 here, and that will give us 40. So that's plus 40 is equal to 25. Now we can transpose this 25 to the side. All right, so we are going to have 5a squared minus 20a, 40 minus 25, that will give us 15. All right, we can see that all the values that we have over here are multiples of 5, so we can divide 3 by 5. We will get a squared minus 4a plus 3 is equal to 0. So now you have this thing to factorize. I think you are going to use negative 1, negative 3, so a minus 1, and then a minus 3 is equal to 0. So you have a minus 1 is equal to 0, or a minus 3 is equal to 0, giving you a is equal to 1, or a is equal to 3. So therefore, the possible values of a are 1 and 3. That's all. You are done. Okay. Then we are told that we should find the coordinate of the midpoint. So we are going to use the midpoint formula. All right. So remember that we said midpoint is the sum of the x values divided by 2. So that will be 5 plus 7 divided by 2. And the sum of y values, that's 2 plus 6 divided by 2. All right, so this is definitely going to give us 5 plus 7 is 12. 12 divided by 2, that's 6. And then 2 plus 6 is 8. 8 by 2, that's 4, right? Okay, so let me clean this. All right, so we have 6, 4. Now you could be given variables like this, so it doesn't change the whole argument that the midpoint will still be, you have 2a plus 4a divided by 2, and then you have negative 3b plus 5b divided by 2. So this will give you 6a divided by 2, giving you 3a. And then this one will be positive 2b, right? Divided by 2, that's b. So this is how it's going to be. So it's the same idea that you are going to carry throughout. Sum of x divided by 2, sum of y divided by 2. That is how to find a midpoint. Okay, now let's see how that will help us in this problem. We are going to apply all that we know to this particular problem. It says the three of the vertices of a parallelogram ABCD are this, this, and that. Okay, first we should find a midpoint of the line what AC. In case you don't know a parallelogram, this is how it looks like. Okay, this is a parallelogram. Okay, but they want us to find a midpoint of AC. So midpoint will be equal to, take the A and C, their x values, that's negative 7 plus 7 over 2. And then their y values will be 6 plus 3 over 2. Okay, so that means that we have 0 and then 9 over 2, right? Or 4.5. Now they want us to find the coordinates of D. All right, how do we do that? Well, we will sketch the parallelogram again, okay? I like to sketch it because it helps me to know exactly what I'm doing. All right, let's call this A, B, C, and then D. Right, we don't know the coordinates of D, so we are just going to put X and Y there. but we know that A is negative 7, 6, B is negative 1, 8, and then C is 7, 3. All right, then in the part A, they made us find the midpoint. Now, let me tell you one thing. Cambridge will not ask you to find a midpoint if they don't think it's going to be useful. All right, so once you have found a midpoint, note that chances are you will use it in the calculation. That's 9 over 2. All right, okay, so now how do we find the coordinates of D? Well, it's quite simple. Check this thing out. For a parallelogram, the diagonals, all right, the diagonals from, let me do it again. Right, so the diagonals from A to C and the diagonals from D to B meet at the midpoint, right? Okay, so they meet at 90 degrees. Now, that midpoint is for both lines, okay? So midpoint basically means that from the distance from A to this point is the same as from distance from here to there, all right? And that is also the same as from the distance from this point to D is the same as from this point to B, okay? So that's the idea that we're going to use to help us find the coordinates of D. Okay, so if that is the case, and we have been able to find a midpoint of line AAC, let's also find a midpoint of line DB, okay? So midpoint of DB. That will be sum of x values, that is x plus negative 1 over 2, and then sum of y values, so y plus 8 over 2. All right, like I said earlier, their midpoint is the same, so this particular midpoint is shared by both of them. Therefore, we can say that our x minus 1, because x plus minus 1 is the same as x minus 1, over 2, and then our y plus 8 over 2, this is the same as the midpoint that we got, 9 over 2, okay? Now, what this means is that the corresponding x values, okay, are the same, and the corresponding y values are also the same. So let's start with the x values. So x minus 1 over 2 should be equal to the x value over there, which is 0, giving you x minus 1 equals 0, so x equals 1. All right, let's work on the y. Y plus 8 over 2 is equal to 9 over 2. All right, so we can say that y plus 8 is definitely equal to 9, so y is equal to 1. All right, so therefore, you can say therefore the coordinates of D will be 1, 1. All right, so that's it. So this is how to approach a question like this. All right, so it's like I said earlier, it's good to draw. When you draw, you can use the notion of midpoint to find the missing value. That's the missing coordinates of D, and then you are good to go. Right, so this is it. Now in the next video, I'm going to talk to you about parallel and perpendicular lines. We can use the same notion of parallel and perpendicular lines to solve for the missing coordinates of D. All right, it's a little longer, but I mean it also works. So I try to give students a lot of options as possible, so that in the exam room when they're confused, they can use this method or that method, any method. That would be cool. So look forward to the video on parallel and perpendicular lines. See you next time. Bye for now.